tasked with the design and construction of a net zero carbon building, including the simulation of the entire life cycle of a design-build project. I now invite the civil engineering team to the stage, please.
Hello? Okay, cool. Hello everybody, and thank you for being here. I am Alex Reitzman, our team's project manager.
I'm Marissa Hernandez. I serve as a geotechnical engineer as well as a civil design lead.
And I'm Lily Yang, and I serve as the principal architect.
And welcome to our Design Build Net Zero Carbon Museum of Art of Southern California, the Civil Engineering Department Senior Project. Our agenda today includes our team organization and our project description, as well as our sustainable and civil design aspects. And then that translates into our design build integrations. And then we finish off with our construction aspects. First off, we would just like to give a big thank you to our project advisors as well as our CPP alumni industry advisors who were able to educate and guide us during our time working on this project. They put in a lot of effort to set this project up for us, and we sincerely thank them for all their hard work enlightening us this past year. Okay, here's our project organization breakdown. As you can see, we are kind of a smaller project. We only have 8 students as part of our project team. And down there at the bottom, you can see that we do have a set of international team members. These are civil and construction students that range from France, more specifically the Conservatoire National des Arts et Métiers. Sorry if I butchered that. These students helped with our garage design and some other structural design aspects, and they played a major role in our design review. We were very lucky to have them, and we thank them for all their hard work, even though they are currently back in France right now. Okay, and without further ado, let's get into the details of our project. Our project site is located along the northeast boundary of San Diego, due northwest along the I-15 and I-8 intersection. While it is currently known as the Snapdragon Stadium, for the purposes of our project, it is a barren field waiting to be developed. Our senior project process began with developing a proposal in response to the City of San Diego's RFP for a net zero carbon museum building. For bidding purposes, we brainstormed to develop various design concepts, which included both cost and schedule with each of these design concepts. And in addition to these designs and costs, we had to provide a certain amount of bondage, a certain amount of insurance coverage, as well as a cover letter, which exhibited our proposed alternative technical concepts, as well as our value engineering efforts. And we even had to include a risk register, which I'll get into later. In our spring semester, we developed 4 construction drawings, and then we finalized our critical path method, our CPM schedule, and detailed estimate, as well as hosted a number of owner project status update meetings. We were able to incorporate sustainable design and construction practices throughout our senior project, as well as solve industry challenges by conforming to our owner's input during our initial design phases. We integrated our individual expertise following the essence of the design-build project delivery method, on top of collaborating with international design and construction students in an effort to deliver the project that we want. Okay, and now on to sustainable building elements.
Thank you, Alex. So our project was unique in its focus on sustainability. So we've been able to achieve LEED Gold. And what LEED is, it's the most widespread green building rating system. And Gold is the second highest ranking. And to achieve that, we were able to incorporate these different sustainable aspects into our building. One of being the wind catcher, which takes natural wind from the outside and has it circulate throughout the building, which also decreases our energy load. We also have native plants on our botanical garden green roof, which that green roof also doubles as a mitigant for the heat island effect. 2 more certifications that we received is net zero energy and net zero carbon. This one is net zero energy. What we see here is the energy consumption of our building that we calculated. It's already very low because of all the mitigating aspects we put in there, like our wind catcher and our heat pump. But we also have solar energy coming in from our garage, where we have a lot of our solar panels, and it'll create 123% of our actual energy consumption. We also have our net zero carbon. So the way we offset our carbon was with our solar panels, but we were able to lower our actual carbon using the material of mass timber, which is relatively new into the construction industry, especially for bigger structures like this. We also conducted life cycle analysis using SEMA Pro, where we analyzed concrete and rebar, as well as our glazing and plywood to determine the amount of carbon it would produce during construction. So we were able to offset that carbon usage in 3.3 years by giving energy back to the grid. Now let's go into our aesthetic design. So we presented a lot of concepts to our building owners, which were our project advisors and industry representatives. And through careful collaboration and communication with them, we eventually refined our design down into our final product, which is this. You can tell that a lot of the aspects of our building came from our past concepts. So we took a lot of those aspects from there to make this final one. You can see there's two circular buildings on the plot of land. The bigger one, including the botanical garden green roof, as well as a large glass dome. Let's take a look at a video rendering. So you can see a lot of the materials that we used. You can see the public park located there and the garage located here. Welcome to the Museum of Art. We first head into the lobby, which is connected to our museum store. And this is where a lot of our patrons can buy little pieces of art, souvenirs, and books. And this is connected to our gallery. This is our Building 1 gallery. As you can see, it's lit up by our glass dome. We also have temporary walls installed, which can be removed and added based on the needs of the museum. Then we have one of our 3 restaurants. Our patrons can come enjoy there throughout both buildings. And then now we come up to our green roof. And there's 2 habitats to our green roof, one being desert and another being more tropical habitat, both including native plants to the Southern California area. And finally, we have our public park, which is free and open for the public to enjoy. Now I'd like to pass it on to Marissa.
So now that Lily has discussed her very ambitious architectural design, it was the civil design team's responsibility to make this vision into a reality. So in order to realize a project of such a large scope required an interdisciplinary team. So we began with the request for proposal from the City of San Diego, which we were able to develop the architectural rendering, which Lily just shared with you. From there, we developed full structural framing plans to support this building. Once we developed our structural plans, we designed a foundation to support them. And then lastly, we provided all of these plans to our construction team. So they're able to develop a comprehensive estimate and schedule to provide our owner with updates. And then lastly, throughout this entire process, our sustainable team was very involved in ensuring we're meeting our LEED and net zero carbon and energy goals. So we'll start the civil design with our foundation design. So the first step in designing our foundation was analyzing the geological hazards of our site. So there are no active faults within a 5-mile radius of our site. The closest fault is the Rose Canyon Fault Zone, which is located 7 miles to the west, so it does not pose any surface rupture hazard. The San Diego River does run along the southern portion of our site, which runs along Interstate 8. However, there is no risk for liquefaction due to the dense sandy soils of our site. Moving on to the foundation itself for Building 1, which is the larger building, all of the columns for this building are located in 2 concentric rings, and the lateral force resisting system consists of timber shear walls, which are located perpendicular to these rings. Due to our elaborate the architectural features, we had a very elaborate structural design system. So different portions of our continuous strip foundation are subject to different loading requirements. So therefore, there were 3 different cross sections that applied to the foundation for our first building. And then next, here is a typical slab-on grade for both buildings. Now moving on to the structural design above the ground. So our structural design was subject to many constraints. The first constraint being the sustainability. So we actually had one of our structural engineers develop an entire design for our building using steel framing. However, once we provided this to our sustainability team, we realized that the recycled steel was not as sustainable as we initially thought. So eventually we ended up deciding on timber for our structure. Another design constraint we had was the large open spans. So this is a world-class museum. We wanted to make sure we kept all these open spaces. So as a result, we had very large spans for our columns. And then also, as Lily mentioned, we have that very large glass dome that needed to be supported somehow. So our team's innovative solution was to consolidate all the columns into these two concentric rings, which are pictured here in orange and blue. And in order to support our roof, we developed these trusses as well. So the truss is highlighted in red, and there are multiple trusses distributed radially along these rings. And the trusses themselves are supported by the rings. So on one end, the orange, the inner ring, and on one end, the outer end, perimeter ring in blue. And then this is our structural framing plan for the timber compared with the architectural rendering.
And now on to risk management. During our time, our team collaborated on a detailed risk register and heat map for all possible foreseen risks our project may be subjected to, generating solutions to some 30-odd possible risks that could only be predicted by merging all of our individual experiences into one coherent project team. One of our more prominent risk events was strong winds halting crane operations. Our response to this was to incorporate both a dollar amount and time contingency into our proposal, which allows us as the design builder to take the lead in mitigating this event should it occur during construction. During bidding, we collaborated internally to unionize our design aspects to our construction logistics and phasing. These review meetings are one of the key facets of design build project delivery method. It drives the design builder to internally generate cost and time efficient design solutions, allowing the owner to capitalize on the internal processes that contractors utilize to maximize profits and minimize time spent on any one of their projects. Take our lightweight cellular concrete, for example. The standard material used as backfill around retaining walls is the engineered fill. Using lightweight cellular concrete in place of engineered fill increases both the load capacity as well as the longevity of our retaining wall by reducing the horizontal soil pressures and the demand loads that are experienced upon the retaining wall. Next, we have estimating. During bidding, we utilize programmatic estimating to conjure up our building price. Programmatic estimating requires a lot of assumptions to be made, meaning our estimate was as preliminary as our design. And to our surprise, our actualized detailed estimate ended up inside the ballpark of our programmatic estimate, meaning that our team was experienced and capable enough to make accurate assumptions during our pre-construction phase, enabling our team to present to the owner a considerate and accurate pre-construction price that they can depend on. Up next, we have our schedule. Here's a chronological milestone single line schedule, which was derived from our critical path method schedule. Our group worked together to generate a logical CPM schedule for bidding, which we then cost and resource loaded upon award of the project. We implemented weekly construction progress updates using our schedule to present to the owner how construction of the project differs from its original conception. As any construction project does, we experienced delays and had to resequence our original schedule to place us back on track to our project deadline. In addition to the plethora of contractual requirements that needed to be met, a stormwater pollution prevention and site logistics plan was necessary for our bid as well. Our SWIPI and logistics plan embedded safety and protection into the foresight required for the actual construction of our building, going hand in hand with the schedule to present to the owner that their building and money is in fact safe with us.
For our closing remarks, we've used a variety of software to achieve our final design. Most of these softwares we had experience with through our Learn by Doing Cal Poly Pomona undergraduate curriculum. However, some of them we applied to learn specifically for this project, so that was a very interesting learning experience for us. And then to summarize our project, one cornerstone of our project is sustainability. Not only was this involved in the life cycle analysis, but in every design choice we made, from the architecture to the sustainable timber we decided for the structure. Another aspect was solving industry challenges. Clark Construction highlighted a lot of issues with our preliminary design based on their industry experience, which was very insightful. Another thing was the interdisciplinary integration between our team. Normally, design and construction teams have very different priorities and it's very difficult to coordinate. However, the design build delivery method of this project allowed us to work very closely and deliver a comprehensive project for our owner. And then lastly, we were fortunate enough to have international collaborators give us feedback on our plans as well as help design our project as well.
Thank you so much for your guys' time, and we hope you enjoyed our presentation.
Thank you very much. Again, to honor the time certain start for the next presentation, we're going to move right along. Okay, so the next presentation is